So I have told you regarding this callback function. This is the main core, along with the Lambda, of functional programming. And this, I hope, is the last time I'm going to explain this. So I have some function 1, which is calling this code from here. And when I'm passing 2 parameters, besides these 2 parameters, 5 and 15, which I have addition and is giving me 20, I'm passing a functionality. Functionality in JavaScript, I'm passing by name of the function, as you can see in here, which this is doing nothing but print on the screen the parameter that is receiving from the caller function. So callee function here is going to print callback called with value 20. So this is the callback mechanism, and I have told you this is based heavily on pointer to functions. So I can have pointers, as you can see, to any data, any area of memory. Could be a picture, could be a movie, could be a exe file, or I mean image, machine code image. But in this case is bytecode. In our case in Java, in JavaScript, yes, is code in the end of the day that is referred by the caller function. And the principle is simple. So for instance, I have 2 entities, entity 1 here in this column, and entity 2, the second column. And as you can see, in entity 2, I may have 2 functions, function 1 and function 2. And function 2, I'm storing the address of this function 2 in this function pointer. In my case, in JavaScript, I do not have function pointers. In Java, I have it, but I cannot handle it. So I cannot see is a function pointer or not. The idea is to be able to store entity from entity 2 in a way to store the entry into this function number 2, function 2. And then when a caller entity, this blue one in here is going to, after this step A, is going on step B to call function pointer, the one from entity 1 in red, as you can see in here. Then on step C, I would have the callback to function 2 because I had the registration step up front. And now I'm calling this function, and then the result is passing to the caller. Is exactly what you have seen here in JavaScript, but you do not handle in JavaScript function pointer functions. Now let's compress this sample before jumping in to see how it's running. Let's compress this sample into this one, second one, where I have the same parameter and same functionality, 5 and 15. Yes, I'm calling some function, not one, but some function with this parameter. 5 plus 15 is giving me 20. But when I'm calling back, as you can see here, as a third parameter with my number, which now is 20, of course, in this case, I'm going to call back this functionality that I have selected. So this functionality that I have selected, as you can see in this PowerPoint slide, is going to be called, and this is an anonymous function which is playing the role of closure. I'm not going to read from the slide, you have the slides, right? But again, so this is a closure into JavaScript implementation. And it is the same like previous sample, but in here I'm working with anonymous functions. In the next slide, we have if in Pojo I can have callbacks. Of course, I can have callbacks, are a little bit scratching besides the normal behavior. In JavaScript is more natural. I can have callbacks in Java 7, for instance, but in Java 8, I fix this via, Sun and Oracle fix this via the Lambda expression. Let me show you what I'm trying to say in words in here. So I'm going to start the virtual machine of Linux. And just give me a few seconds. Okay, and let me show you what is about right now. So let's continue with this sample in JavaScript in order to understand better what is about the functions, callbacks, and the closures, and of course the Lambda. So as you can see in here, I have a source code in the source folder as you get used in lecture number 7. not in functional interface, not in Lambda. I'm going to come back into this, is important, but in Nashorn.js. Nashorn.js again is deprecated and is replaced by GraalVM in Java in order to support ECMAScript, so JavaScript 10 plus according to specifications. And let's stick to this sample P001001 C underscore function callback. I'm going to open this with gedit, GNU editor, and let me show you what I have in here. So first of all, if I want to keep the sample from the PowerPoint, then I have to comment console log, and therefore I do not have this kind of Lambda. So I'm just simply having something like this, as you may see, and I'm going to just run because I have explained and I told you how is this called. So I have some function, and this some function 5 and 15, I have just to call it. As you can see in here, I'm calling it this implementation that I have it in line 3 up to 9, and then I'm adding these values, and then I'm calling back this anonymous function. So it's going to work this like just like this. So I'm going to get the environment variables, as you can see, the export. And instead of running with Java, I'm going to run with GGS. So for Nashorn. For GraalVM, I simply have Node in the bin folder of GraalVM. So let me open a terminal. Okay. And then in this terminal, I'm changing the profile. Okay, to stud3. Is it anybody who wants the larger font? Okay. As long as you see this font, I'm exporting the environment variables, and I'm going into Home Stud Java Standard Edition Java AC Lectures C07 sources. And here in sources, if I'm listing the folders, I don't want to discuss base64 date and time for the moment. I want to go in Nashorn.js. And in here, as I have told you, I want to discuss this P001 C underscore function callback. So let's run this. And as you can see, when I'm running this with GGS, I'm going to obtain the result that we already forecast from the PowerPoint. Right? So this is running, of course. I have in line 10 is not a file in line, I have exception, not a file. Oh, because yes, because I'm already in this folder. So I'm going to run again, right? And is expected another end of file is expected in here because this console log. I do not have console log in Nashorn. I have only printf. So I have to save this. Save. I did not save. And right now, I'm pretty sure I do not have any console log. So in this moment, it's going to fly. Okay, so we have callback called and value 20. Everybody should be happy. Now let's do a more complex approach, and with this I'm jumping into Lambda, preparing Lambda for Java. And instead of using print, I'm going to use console.log, because the same program, in addition with this Lambda expression, I'm going to run with Node.js. And let me show you. So what I do in here, this is the second call of some function from here. So I have two calls in a row. This is a call where the third parameter is functionality and is closure, is an anonymous function. And the second call, this one, I have other two numbers, 23 and 7. Of course, their addition in here is going to be 30, which is normal. But the callback in here is going to call back the Lambda implementation in JavaScript. So as you can see, I cannot put whatever number of parameters I want. Why? Because I stated that I'm going to call back with one parameter in here. In Java is more restrictive than you are going to see in a bit. So right here, what you see is a functionality, but instead of using the keyword function, I'm simply using the list of parameters, which in my case is 1, and result sign equals greater than, and then I have the begin statement, end statement, and I'm doing whatever I want to do. Is the same functionality that previews I have with anonymous Clojure. Okay, this being said, let me run again, but not with GGS, as you can see in here. Right now, I would run, let me show you, with from opt folder. You can install on Windows or whatever you want, Node, right? Node right now, if I do not mistake, is on version 12. I have it on this Linux version almost 9, 8.9. And let me run. And yes, I have to comment print, of course. So in here, I should not have print anymore. It's commented, but I did not save the file. And let me run again. And now it's going to work. This is the 20 from our Clojure function, and this is 30 from our Lambda. This being said, and you have seen what is Clojure and what is callback and what is Lambda in JavaScript. Of course, in our days, is possible to call them from GraalVM exactly like from Node.js. Is the same syntax. I don't have to comment and to rerun and to see that instead of printf, I have console log and vice versa. I simply run them. With this, I'm going to jump into the concept of functional interface into Java. And in functional interface into Java, besides what you have here, a lot of new functionalities. So I would like to stick a little bit about the theory and said, okay, functional programming is not versus object-oriented programming. So object-oriented programming is very good over abstracting data, right? But functional programming is very good over abstracting behavior. So in my case, in Java, we are using as a multi-paradigm, object-oriented programming and functional programming as a complementary paradigms, right? So we are not going to exclude them. We are going to live with both of them at least in order to have a better program and in order to have a better functionality in the end of the day and handling better the data. And you are going to see immediately what I'm trying to explain in here in theory. You are going to see in examples. And with this, of course, you have a lot of samples here in JavaScript in order to highlight how you are calling code from JavaScript, and vice versa, from JavaScript back to Java. So you have it in this. So I'm going to jump in these two folders, functional interface and Lambda. And for instance, in functional interface, I have this Java 8, for instance, tester functional interface. Let's try to discuss this, right? And this, yes, I would like to discuss, but besides this, I want to discuss also from Lambda, more important. I want to discuss this Java 8 tester Lambda. Okay, so what we have in here, let me explain a little bit. So as you can see, I have interface mat operation, and then I have interface greeting service, but let's stick with this sample for a while. So this interface mat operation is having only one function. Of course, I can have multiple methods into my interface, but a functional interface is having only one functional method, and that functional method is exposed outside the world of the interface. What you can see in here a little bit different than interface, like in annotation where I had add interface, here I do not have add interface, I have interface keyword. And then I have this annotation, which is add functional interface, very important. This being said, what I'm doing, several lines below, from line 13 to line 18, I'm doing a class, which, like in the JavaScript example from the few minutes ago, I'm having an operate function, which I'm receiving two objects, A and B, could be X and Y, doesn't matter. And the third parameter is called mat operation, but please take a look, closer look. What is the declarative type for this object, third object? The declarative type for this object is mat operation. So is an interface, but not any interface, but a functional interface. Therefore, this is the way I can send in Java, for instance, functionality as a third, fourth parameter, doesn't matter, as a parameter to a method within a class, that is going to be called from an instance or other instance of this class objects, therefore, I can send functionality. And this functionality, let me show you how it's handled. So in line 16, I'm saying, look, from this object, I want to call this function operation. In this moment, I have no idea what kind of functionality could be between two numbers of integer. Could be a at power of b, could be a multiply with b, could be a plus b, could be whatever operation. But in this moment, from line 3 up to line 18, I have no idea what kind of operation is going to be. I even can encapsulate this and provide it as a Java archive bundle. And we have discussed Java libraries, Java archives 7 days ago. Please interrupt me if I'm wrong, but I remember we have discussed. And therefore, let's move forward with this Lambda sample. What you see in here, I'm creating object OP from math operation. So from this class that I implemented in line 30. Starting with line 30. And for this OP, as you can see, I'm going to prepare the call of OP, as you see here in line 36, dot operate above and for these two parameters, 10 and 5. I'm planning to do what? Addition between these two. How I'm implementing addition? Addition, as you can see in here, selected in line 36 at the call, is implemented in line 25 as a Lambda expression. So in terms of functionality, you can assimilate as analogy is as it is, but I mean, it's not like this, but it would be to understand as an analogy better as a pointer to a function. Look, my addition is having declarative type that interface, which is functional interface, and the real type is like a pointer to a function which is doing this functionality, a plus b. As you can see in here, I'm receiving two parameters, and for these two parameters, I'm returning the result a plus b. So I have this, if you want to put codes as analogy, addition is a pointer to a function with declarative type functional interface math operation. Then in line 28, I have subtraction. Then in line 31, I have multiplication. This is the most full how to say, full implementation of the Lambda. And as you can see in here, you may ask why I did not send parameter C of type float or of type double. I cannot do this because the signature, yes, I can have any type of function, any type of method in here with any signature. I can receive 3 parameters from satellite class and returning void, or vice versa, returning a student from array of students. Doesn't matter. So I can have any signature, but as long as I have in this case a signature, for instance, this int 2 parameters and is returning int, is mandatory that my Lambda to be compliant with that functional interface method signature. So in here, I have A and B. That's why in here, as you can see in more compressed form, is not necessarily to have curl braces, is not necessarily to have the type of parameters A and B, because the compiler knows I cannot send anything else but int and int, as you can see in here. And I cannot return anything else type than int, exactly like in the signature in line number 5. You will see immediately for greeting service, I have a different signature. So I can have any kind of signature. Therefore, for instance, as a head up for the multi-threading next lecture, I have runnable interface in Java lang package, right? With public void one method, which is a functional method. Therefore, I can have threads implemented as Lambda expressions, and we are going to do this. And again, so the signature is not mandatory. I can have whatever signature, but once I have it, like in here, right now, let's stick to this sample, line number 5. Therefore, all my operations with declarative type functional interface must have 2 parameters of int and returning 1 parameter of int. As you can see in here, I have declared these Lambda expressions, and I'm simply using them in op.operate. op.operate is receiving 2 objects, A and B, and then the third one is functionality. When I'm declaring this functionality, no, I did not declare when I have created class mathop from line 13 to 18. No, I did not do this. So I did later on. I did, for instance, in line 34. I did in line 31. I did in line 25. So I did it later on, and then I have called it. As you can see in here, I have op.operate over 10 and 5, and then what I'm going to apply to them. Look what I have said in here, addition, then subtraction, then multiplication, and then division. So these are operations I'm going to do, and I'm going to do with Lambda expression. Now let's see another approach regarding this Lambda expression. Another approach is this greeting service. You see, in greeting service, I have a functional method within functional interface, which is returning void and is receiving a string. Look in here how I have. So I have message is not necessarily to put, I can do it, but I cannot do. I mean, it's up to me to say, look, this object message is from class string, is implied because I am compliant with that method from that functional interface, in my case, greeting service. And therefore, I know for sure I have only one parameter, and this one parameter is string. Now, what I'm doing in here, as you can see, I have a system out print line hello, right? And then I have a system out print line hi. When I'm going to call in line number 49 and 50, same message for Jake and same message for John, as you can see in here, this message from greeting service 1 is going to be replaced by real parameter Jake. And this message from greeting service 2 is going to replace by the real parameter John, right? And what I'm doing in here, I'm just simply system out print line. So I did not use an intermediary class, which is having another method. I want to show you a different approach, where in this method, I'm receiving as a functionality the third parameter, like in the JavaScript example. No, I'm doing directly the Lambda in here. And once I have the implementation, I simply call the implementation with, again, exactly like I had function method operating functional interface. Here I have say message. Are any questions till now? As you can see, now I have a question for you. Please tell me, for instance, in here, in the math operation, the sample with JavaScript, right? Please tell me which expression, which statement from line 20, 25, 28, 31, and 34 you like most, right? Thanks. I'm waiting for your answer in chat or even on the mic. Okay, so most of you selected the most compressed form, this line 28. This is good. Now in here, of course, this is the most compressed form, for instance, 42 and 33. If you want to have more compressed than this, I can use it instead of full message. I can use M in here. And let me compile this to see how it's working, right? And here I would use the full implementation, and I would say, okay, this is an object from class string, and the implementation starts in here, line number 46, and ends in here in line number, in this case, 48, right? And this 48, please do not forget the end statement to be closed with semicolon, like this. And then finally, I have this full implementation. So most of you are saying, look, is enough to have, for instance, this line 42, which is more compressed and is more clear maybe than line number 45 up to 47. This is more didactical one. This is, yes, more compressed one, and you are going to see in all the sites like this, in Stack Overflow and so on, Quora and other websites for Java, you are going to meet this compressed form. Let me save this and let me run Java 8 tester lambda.java. So for this, as you can see, I'm going to jump over topic number B, right? Java nested classes samples. It's up to you to go in further details. What means non-static nested class, non-static nested class with inner class, non-static nested class, or also with local inner class, and static nested class. So you have these samples, please go through them. I'm not going to insist them in the examination, but it is necessary to know. Also the method references and default methods, for the moment, I'm not going to insist over them. So let's stick to several things. So first of all, I want to jump into this Java 8 tester lambda, right? And the order from this cmd compile.txt file is giving you the order of learning things. So we are into lambda, and this folder is giving to me also the package. So I'm going to copy this and to say in here clear, and let's compile. Of course, I'm going to obtain the class file, the bytecode after Java C compilation. And now let's run this. More or less, this is going to be a sample in our lab, and it has been on Monday. And as you can see, yes, 10 plus 5 gives me 15. 10 minus 5, 5. 10 multiplied with 5, 15. And 10 divided to 5 is going to have 2. And here I have hello, Jake, and hi, Joe. So the functionality is acting like we have discussed. Now, let's move forward a little bit. And let's stick for a while to this closure sample. So I have, as you can see, if in my case, yes, I have obtained several classes. I have obtained Java 8 tester lambda.class. I have obtained math.op.class and math.operation.class. And then I'm commuting to other samples. So yes, for each, let me show you, from my Java text file, for each class, right, for each interface, I have obtained class files. I have obtained for math.op, I have obtained for math.operation, I have obtained for Java 8 tester lambda. So I have obtained for each one of these entities, I'm going to obtain .class files. Now let's move forward, and moving forward meaning to discuss in here, for instance, not this sample because I want to do it a little bit more complex. So in function interface, to answer to Philip questions regarding R Lambda Clojures functional interface. So let me show you. I'm jumping into functional interface, and then I'm pointing to the streams as a discussion. So here I want to highlight this R Lambda Clojures functional interface. So you may ask, for instance, I have a function, make fun, without parameters, but the type for this function is, as you can see, the returning type, if you want, is function of integer and integer. Stop. And for this, I'm commuting to the PowerPoint, and into PowerPoint, I want to show you something. So when I'm jumping over this lambda, and what is lambda? You have here a lot of theory. So for instance, as an analogy, few years ago in C#, I had C# for object-oriented programming and F# from Microsoft.NET for functional programming. They united now in C#. I supported these two paradigms as well, object-oriented programming together with functional programming. In Java 8, starting with Java 8, we have object-oriented programming and functional programming in same language syntax, right? And it's kept up till now in Java 14, right? The latest release of Java. And you have it in here in terms of related to the syntax, how you declare, and you have several things in here. I want to finalize the Lambda discussion before jumping in that topic, if Lambda are closures. Let me show you, for instance, in Java 7, how I was sorting, for instance, a list of names. If I would have a list of strings, right, names, I can call sort static method from collections. And here I'm passing as a parameter object names, which is a list of string. And finally, as if you want closure in here selected, I'm passing an anonymous object from an anonymous class, which is implementing comparator interface. What is comparator interface? Please take a look in here. Is a functional interface, the one with red, not the one with red, right? This one is a functional interface comparator. And in this functional interface, I have several methods, but only one abstract method are allowed, right? So overriding allowed, yes, I can override allowed, like equals and so on from the previous interface. But only one abstract method are going to be functional method. This compare, for instance, this compare objects O1 and O2 from the same class T, whatever T. Now is generic programming. So because it's generic programming, as you can see in here, I have an anonymous object from an anonymous class, which is implementing a functional interface, not any interface, where T, whatever T, as you can see in here, type name T with capital letter T is replaced by string. And I'm myself, I have to stick to do what? To provide implementation for its own only one abstract method allowed. I mean, compare, of comparing object O1 and O2. In my case, parameter, I want to put whatever name of parameters, S1 and S2, from class string, and I want to return in this compare what? a int, which is provided actually in behind by non-static method compared to from Java lang string, which, as you know, as a comparison, an analogy could be with string compare from C, strcmp or ncmp, string compare, which means if first string is less than the second string, I'm going to receive -1. If they are equals in terms of content, I'm going to receive 0. And if the first string is larger than the second string, I'm going to obtain +1. What means bigger? First letter in the ASCII code is having a code larger, bigger than the second one. And that's it, this is bigger. Okay, and as long as I have this is in Java 7. I'm going to sort the list of my name if the in my case they are compliant with compare to. So the string order is giving me the order in my list of names, right? This is one thing. But starting with Java 8, because I have access to Lambda expression, I can provide in here, in terms of closure, I can provide Lambda expression. So more or less, I'm answering to you, are my Lambda expressions closures functional interfaces? Yes, are in Java, but of course you have to pay attention. In addition to the sample that I'm going to jump back in Linux to show you, please take into account, I have several predefined functional interface. As I have told you, and you are going to see after 7 days, I have the runnable interface, which is receiving for abstract method void run, which is returning nothing, and I have run, is receiving 0 parameters, none. And okay, this is void run that can be a Lambda expression in the end of the day. And we are going to see after 7 days. Now I have several functional interfaces that are predefined starting with Java 8. One of them is function T and R, generic type T and generic type R. As you can see, the parameter types, the method is apply, abstract method name. The function is receiving one parameter from class T, whatever T, and then look at my mouse, and is returning one parameter from class R, whatever R. And exactly the same, we have it in here. As you can see, I have a function of integer and integer. Integer is the parameter that is receiving, and integer is the returning type. You are going to say, look, but make fun has no parameter. Yes, make fun is a function which instead of returning void is receiving no parameter, but instead of returning void or int or whatever other type, student or satellite, is returning an object from with declarative type of functional interface with named function of T and R, whatever T and R, and in this case, whatever T is integer and whatever R is yet another integer. And look how I'm returning in here. I'm returning functionality. So what I'm trying to highlight in this sample, I'm trying to highlight the fact that not only by receiving parameters like in previous example, in Java 8 tester Lambda, where I receive besides A and B, I receive the functionality as a Lambda function. I can, yes, receive a functionality as a parameter. I can return a functionality like in here. And as long as I'm returning like in our Lambda closures functional interface, and as I'm returning a functionality, please, let's try it. So what I'm going to do in here, I'm going to call from anonymous object our Lambda closure. Our Lambda closures fi, this is the class that I'm discussing. I'm creating an anonymous object, and from this object I'm going to call non-static method try it, which try it is receiving no parameters, is returning void, but is having two objects, x and y. X and y are calling each one of them make fun function, right? And as long as they are calling make fun function in here, this make fun function is receiving 0 parameters, but is returning an entire object with declarative type function integer in integer, which is functionality, which in my case, the functionality is going to be what? A system out print, so printing on the screen what? This n equals 0, which is inside on the stack of this make fun function, the variable n of 4 bytes, an integer, and then the argument. And you are going to say, for real, what is the argument? And because I'm incrementing, then I'm returning actually the value for this functionality. I'm returning what? N, which is 0, plus argument, which is +1. And I'm going to show you how it's going to run. So x and y are variables, which are in the end of the day lambdas because I'm returning a lambda in here. As you can see in line 18, 1920, x and y are going to be filled with exactly like a pointers to a function, so to functionality expressions lambda. And as long as I have this, as you can see what I'm doing x dot apply. Who is apply? Apply is a method, as you can see in here, apply, a function with argument of type t, compose and then identity. And this is what I'm calling in here x apply. X apply is doing nothing else but actually calling this functionality for applying. And in the end of the day, I'm passing as a parameter for apply, as you can see in here, I. And let's see this I, how is going to be sticked. It's going to replace this arg. So I have a for I int I equals 0, I less than 5, I in each step, I0, I1, I2 until I equals 4, because 5 is less than 5 is not less than are equals, are going to jump out from this loop statement, 21 and 22 lines. So coming back into this, I is going to replace arg. So what I'm going to say, okay, system out print n, whatever value is having n, space, and then my I, which is going to be from 0 to 4, including 4. Now moving to the next statement, 23 and 24, line 23 and 24, I'm seeing here another yet 4, where I'm calling apply for y, which y again is going to replace arg with values of y. This is for sure, but n, let's see n. Let's compile this and let's run. And let's see how is this intuitive example, which actually is asking yourself, are lambdas closures functional interface? And somebody already asked me. And of course, you have a lot of more samples in here, but I'm sticking to jump into streaming processing, right? So please allow me to do this. So I'm compiling, and then I'm running, right? So as you can see in here, I had what? I had always n is 0 because nobody else is going to modify this. But let me show you again the source code in terms of printing on the screen. So always n is 0, but I have argument which is going to be equals 2 point space, and then as you can see here, I'm incrementing the argument. And once I'm incrementing the argument, because I do not have in here system out print line, I have system out print. In the next iteration, the previous argument is increment by 1. So as you can see in here, I have 0, and then I have 1, and then again this sample with 2 point space. Then I have 2, and again this one, and so on and so forth. So it's correct to say more or less that are lambda closure functional interface? Yes. Now let's move forward with the sample. And with the sample, I'm going to jump into streams, right? So we have discussed minimal about Nashorn and actually JavaScript. We have minimal discussed about functional interface and lambda. Let's move to the streams, right? So into the streams in here, I have a sample. This is sample 2, and this is sample 1. Let me open both of them. Please interrupt me and feel free to interrupt me whenever you consider necessary. And in here, in this sample 2, please take a closer look at home. But in here, I have, as you can see, a enum type, task type for reading, coding, and loading for you as a student. I have a class, for instance, task. So you have a task for, let's say, on Monday to do your assignment, which is going to include to read a book, for instance. What book? So I have a title, I have the description of the book, and then I have task type. Task type meaning what? Not coding, but reading and not blogging, right? Reading that book with that title. And then I have the local date, the creation, and then I have several tags. If it's a book about Harry Potter, which is not the case, we are doing computer science, or it is a book from whatever Java Essentials topic, right? And in here, I have several tags like computer science, like Java programming, like multi-paradigm programming. And this is my class task. And in this class task, of course, I have overriding to string. And then I have some data utils, as you can see in here, and this data utils is doing for get task what? Is compiling, is creating a list of tasks, task 1, task 2, task 3, task 4, and task 5. And I have read Java 8 in action, write factorial programming in platform language Haskell, or read effective Java. By the way, this effective Java third book, you have it as a second reference into the bibliography provided by me by Joshua Bloch. He's a very good, very good book. And write a blog about a stream API and so on. Write prime programming with a program in Scala, which, by the way, is yet another Java JVM based language. So you have several tasks in here as objects, and I'm returning list of tasks. Let's take a closer look, right? And a closer look meaning, what if in my Java 8 stream examples, I have several functions, methods into this. They are not static, non-static. And as you can see in here, I have what? I have tasks, which is a list of tasks. I'm going to stream them to put in a functional stream. Again, stop. So till now, we have discussed about byte level oriented and char level oriented on 2 bytes about input-output streams, right? File input stream, file output stream, print writer, and so on and so forth. So we have discussed about classes, which allows me in programming to transfer bytes from volatile memory, from random access memory, to non-volatile memory, to storage, which is the hard disk, solid state disk, whatever disk I have. This we have discussed 14 days ago. Now in here, we are going to discuss about different streams, right? So we are in this topic of streams, right? In this lecture number 7. And in these streams, these are functional programming processing streams. So I'm processing with this. And as long we are going to discuss about this, let's stick for a while and let's see what we have it in here. So this is a function, for instance, all reading task, where I want to filter all my tasks that are related to reading, for instance, a book. So what I'm going to do, from my tasks, as you can see in this line 110, I'm receiving these parameters of tasks, and I'm going to stream them. And after I'm going to stream them, please read in here what I have. I have a filter, then I have a sorted, and then I have a map, and finally I have a collect. And you know, a picture or a movie is doing 1,000 words at least. I'm going to show you several pictures because, for instance, this method that I have implemented in here, I'm going to call in the first in this principal program. So all reading tasks, yes, I have all reading tasks sorted by creation date. I have all reading task period, and then I have already the counting on them. And I have to is already in task with tag books, right? So I'm asking myself if they are tagged with books. And finally, the fourth, yet another method, I'm having this already with tag books. And now what I want to do is to see how I'm calling them. So I'm looking for a public static void main. I have a lot of things in here, and I'm doing what? I have my reading task, which is the task, as you can see from data utils. I'm receiving all those 5 tasks in a series, like, let me show you again, in a series like a list from Java util, right? List of T, whatever T is, in my case, class task. And you see in here, I have received task 1 up to 5 is a stream of, right? And then collect to list. So I'm receiving the list. And with this list, I'm fooling around, I'm playing around in order to highlight the functional programming processing streams. And then what I'm going to do, filter them, sort them, map them. Stop. Let's stick for a while now back to the theory. So what I have in the theory regarding this processing streams. So in the theory, I have something like this. When I'm working with functional programming processing streams, so briefly speaking, Java, starting with Java 8 processing streams, is like I'm playing with SQL language, right? Structured query language in databases. So for instance, I want to select maximum salary, employee ID, employee name from table employee. This is a statement that I'm typing into a SQL Plus client program or my SQL client program, connecting into a database. And as long as I have this table and these columns in my table, I'm able to select them, right? It is relational algebra in behind. Now in the stream processing, in the same manner, I'm going to do what? And I'm jumping to this picture. I'm going to do filter, sorter, and map. Stop. What? So I have a transaction, as you can see in here. List of tasks is my sample that I have shown you on the screen in Linux, but I want to highlight better in the theory. So I have list of tasks, get tasks is what I have. So I get my stream of tasks, where in the second line, tasks, this is the list, I'm going to stream them. So create a stream on a source collection. And then I want to filter. What is receiving a filter? Is receiving an object with declarative type predicate. Stop. What is predicate? I'm going to come back in this slide number 57. So predicate, if you are looking closer attention in here in slide 46, so almost 11 slides up, and you are going to see that predicate in here is stop. Look, where is my mouse? Predicate of t, whatever t, is having function method test, which is abstract method, which is going to receive to be called for Lambda expression, which is receiving a parameter from class t, whatever t, in my case is task, and is returning Boolean, not something else, not int, not void, is returning true or false, Boolean, right? And then is asking itself if is equal or negate or whatever. So coming back into my expression in here, I have a filter mandatory, an object with declarative type predicate, which is a functional interface. And yet the implementation, how is going to be? Yes, is going to be t, whatever t, in my case is list of tasks. And as long as I did stream function, stream method here, I'm call it without any parameter, non-static method, I'm going to play full around with streams. And then I have to submit to this filter an object which is a Lambda expression. And in Lambda expression, I'm doing what? Tasks, arrow minus greater than, so is arrow. Now is the implementation of Lambda, which must stick to return true or false. And I'm doing what? Task get type equals, I'm asking myself if is equals with the enumeration reading from enumeration task type. And then I'm going to receive true or false. Then I'm doing what? I'm doing sorted. Sorted may receive is not mandatory. The sorting of this may receive, for instance, an instance from comparator. Stop. What is comparator? Coming back in slide 46. Comparator again is yet another functional interface. So as you can see in here, maybe I do not have it, or maybe I have it for sure, comparator, but I have shown you one slide or few slides up front, the one with this one, right? Comparator in here is a functional interface with compare method. So, and you have seen the implementation is in this slide 40. So coming back to our 57, I can provide a Lambda expression for saying what a task one, why a task one is less than or greater than task two. Is the name of the book in terms of strings greater than? Is the year of publishing greater than year of the previous one, and so on and so forth. Here, I did not provide anything because I'm relying on the sorting, automatically sorting. And then I'm doing what? I'm doing map. Map, what is receiving here? A function. Function, I have shown you in the example of previous example, is yet another functional interface and is receiving a reference to a function. So it's not receiving any other thing but a reference. And what you see in here is like a pointer to a function is receiving get title. And then finally from task class, I want to call, look, this operator, 2 points, 2 points, exactly like get title, to print line with for each element. So what is happening in behind? So I have a stream source, I have operation result, I have create instance stream, I have terminal operation, and I have several operations of filtering, sorting, type conversion, mapping, and so on and so forth, and operations. So this why is called processing streams. Now let me show you more clear what I did in here. So in order to jump into this explanation before running into what I did, for instance, for this, right? So for this sample, right, I want to highlight with simple integer numbers what is better and what is not, to understand what is mapping, what is filtering, and so on and so forth. So as you can see in here, I have for obtaining of streams several methods. For instance, stream method, non-static method, or parallel stream from collection. But I have several others in here, in this column. For intermediate operation, so like map, filter, and so on, flat map, sorted, that you already have seen, I have this from these classes in the second column, in the middle. And for terminal operation that I'm counting or not, I'm doing statistics like min and max, or I'm calling yet another functions like in for each or in collect, I'm returning yet another list, right? I have terminal operation. Let's stick for a few seconds what is doing filter. Here is the Lambda expression in JavaScript, but can be adapted very fast to Java. So I have a stream input stream here above, and below I have the output stream. And as you can see, I'm filtering this integer number, saying, look, I want to filter not all of them, but where x is greater than 10, which means 2 is not greater than 10, therefore is not going to pass this filter, is not going to land into the second stream, in the output stream. Then 30, yes, is greater than 10, is jumping here. 22 the same, 5 not, 60 the same, and 1 not. So filter applied to my input stream is resulting in an intermediary stream of 30, 22, and 60. Moving forward, yet another operation, map. Map is doing what? Is taking any object and is applying a transformation. For instance, in this part of the numbers, I have 10 multiply with x, right? 10 multiply with x, meaning 1 multiply with 10 is becoming 10, 2 is becoming 20, 3 is becoming 30. So I have the, again, input stream and the output intermediary stream, and I have map. Finally, I have map and reduce, for instance. And for map and reduce, and the famous map and reduce, I can I provide to you in here a sample that I have done in the seminar, and I'm going to do in the seminar. For instance, I want to count all the strings from this list which are having, for instance, length 0. So like this string from here and this string from here. But I'm coming back to the seminar. Let's move back to forward. Let's move back to our sample of tasks, right? Grocery task, reading task, or whatever task. If I would have grocery inside of transactions, I'm trying to enlarge this slide. Allow me please to have like this. I hope everybody see this, and then come back to our sample, right? I would have a list of transactions IDs. I want to obtain the list of transaction IDs which are fulfilling certain conditions. So let me show you. I have transactions.stream, right? So I'm streaming them. Then this is the input stream, all the transactions that you see in here. So transaction 1 of value $100 or euro or even lei. Then from Romania, we have ID 3, 80, 6, 120, 7, 140, 10, and 50. So these are transactions more or less as an analogy to our, for instance, I'm trying to show you different samples. Analogy with our sample that you are going to see immediately is the one about tasks, right? For reading, blogging, and so on and so forth. We have this analogy. So it's a complex object from a complex class, or a little bit more complex than integer. Then I'm going to do what? I'm planning to filter only the transactions that are related to grocery. So not necessarily related to the car maintenance, not necessarily to buying books from Amazon. So I'm just want grocery, meaning going to the mini shop and buying from there. And I'm selecting only the green ones. How I'm doing this? The type of the transaction, if is transaction grocery. So I have filtered this exactly like I have filtered in the integer side the ones that are greater than 10. You see, I'm filtering the one that are grocery type. Then moving forward, I'm doing what? I'm going to sort them. Sort them according to what? Please look in here. So first of all, let's focus about comparing. So I'm sorting them about what means the value. So I'm sorting first of all, taking into account the value, but reversed. Reversed meaning the larger value is first, look in here, reversed, 120. Then I have 80, and then I have 50. So 3 replace the ID 3 replace the place with ID 6. So I have 6, 3, 10 in terms of ID, but of course in terms of value I have 120, 80, and 50. And finally, I want to map. And to map what? To extract. And let me show you here the map. So I want to map, instead of multiplying x with 10 and from 1 to obtain 10 and from 2 20, I want to map in here. What to map? I want to map the ID. So I want to extract simply the ID with get ID with like a pointer to a function reference get ID from my class transaction, right? So if I'm coming back yet to another sample in here, as you may see in here, I had the filtering, I have a sort, and then after this sorting, where I'm passing the lambda expression, which for me is very important, for instance, to sort taking into account the length of the title, it might looks like this, is then mapping related only to the title of the book. Get title. Get title what is a reference to a function. It's like a pointer to a function. From which class? From task. Let me show you again. In here, I have task and I have here get title. Is the method. That's it. Is a reference method. The same in here, in this sample, I have transaction. And besides filtering the grocery and sorting according to the value, I have to map taking into account the ID. And I'm getting 6310. What you observe, in few lines of code, I was able to do a lot of things. Filter, sorted, map, and obtain this 6310. This, and I did in the laboratory. You cannot do it by yourself. Just you have to write a lot of for and while statements to do this in classical object-oriented programming. This is functional programming. This is the power of functional programming. I'm going to run the sample up front, but before jumping into that sample, please take in mind, if you would have a vector and you want to sort it, what you are going to do? You are going to, or at least, for instance, you have an array of strings and you want to highlight how many of them are having the number of letters equals with 3. You have to have a for each and go element by element in order to obtain the exactly number of strings. So you have read-write operations, you have collections are about data, and then you have to do iteration over your collection. But here in the stream, you have only read operations, so you are not modifying the input stream, you are obtaining yet another stream, okay? Is lazy evaluated. Later on, you are going to find out about the lambda expression that is going to implement your business logic. And streams are having internal iteration. So you don't have to specifically put for each operation. Automatically goes through all the operations that you have. This being said, so automatically goes through the entire list that I have in here, like the map in here. So is automatically going through the entire list. And for this, we have the samples from the labs, from the seminary, all of them from the lecture and seminary, you know very well, are in the GitHub. Of course, if I want to run this Java 8 tester processing team streams, you have this example 2 that we have discussed, but you have also the first example. And first example is related to a string, you see? So what I'm trying to say in here, right now, I'm finding out the number of empty strings, which with putting my eye in here, I see I have only 2, right? 2 empty strings. And then I want to run this. And then I want to find out which the strings are having 3 letters with length 3, A, B, C, E, F, G, and J, K, L. So I would have 1, 2, 3 is a coincidence, right? So instead, for instance, of getting this with Lambda, in Java 7, I have created functions for you in Java 7. And as you can see in here, right, I'm providing to you these samples. Let me show you where I'm going with this for. This is standard object-oriented programming approach, which has been replaced, as you can see in here, simply by saying like this. Let me show you. This is with Java 7. And now if I'm using Java 8, look, I'm saying, okay, from my list of strings, I want to stream them. I want to filter them. As long as I'm filtering them, I'm asking myself if the string is empty, or in my sample case, if the length of the string equals 3, so is an object with declarative type functional interface predicate, which is returning true or false. And then in the end of them, I want to count them. But if I don't want to count them, I want to obtain a list. I have collectors to list. So long story short, please, in the streams area, run these 2 samples from here, Java 8 tester processing streams, along and together with Java 8 stream example 2. And you are going to have whatever you need, right? Let me, because I have said this, you are going to have whatever you need to understand the lab that is already recorded in YouTube. So in here, as you can see in command compile, I'm going to, processing streams is enough to have something like this. Sample 2, right? And first sample. And I'm going to run. And of course, you can do benchmarking to see what is faster and what is not faster. So Java C, and finally, right, this was the running of the strings with Java 7, I mean with object-oriented programming, and then with streams. Please take a closer look into this in parallel mode and not in sequential mode. And in here, finally, and with this I'm ending my lecture, you have the samples to run with Java 7 and Java 8, the samples from the that class task, reading, blogging, and so on and so forth. I'm not going to discuss about new data API base 64 and so on. Maybe next time. Is not so important. You have the input for them. So as you can see, this is what I did. All these thing tasks, top 2 readings, and top 2 readings, if you are looking into source code in here, you are going to find out. That's it on my side. If are not questions, you are free to go. But before this, let's jump directly into Kahoot. Let me stop this.